Good morning and good evening, everyone that's joined us today here for our webinar. My name is Stenko Nikolic. I'm the Technology Manager here for the Hydrometallurgy and Pyrometallurgy teams at Glencore Technology. Today, I want to welcome you to joining us, but before we begin the webinar, I just wanted to set a couple of ground rules in terms of how we're going to manage the session. The first thing that I wanted to highlight to you is that this webinar is meant to be interactive. We want you to ask us questions, but what I wanted to highlight is we're not going to be answering questions live during this part of the presentation. We have a panel discussion, which is going to happen after this initial presentation phase. But what I wanted to highlight there is that we're going to be answering these questions on a first come, first served basis. So whilst myself and my other speaker, Paul Bullock, are talking, if you have a question and you want it answered during our Q&A session, get it in thick and fast so that we can get to it at the beginning. Now, rest assured, if we don't get to all of the questions, because I know we have limited time during this session, we will then look at answering all of these afterwards, and then we'll be sending an email to everyone regarding with all of the details of the answers to your questions. Now, in case you get disconnected or there's an issue with your audio or video, don't worry, this webinar is recorded and then you'll be sent a link so that you can view this after the fact. So therefore you can catch up on everything that we talk about or have a look at anything of any things that you want to investigate in more detail. Now, raise a hand if you have some urgent technical issues. Otherwise, we're going to jump in now to the webinar. So what are we talking about today? Today, we're talking about your gold production plant, your gold mine, and we're looking at, where are you in the actual gold production cycle of your plant or the life cycle of your mine? When you start up your mine, you're looking at accessing all of the oxides which are at the top of your ore body. That's where you've got free milling gold, and that's where you have quite good recovery through a standard CIL circuit. You're able to achieve very high 90s. It's very easy gold to then access and recover. But when you start going deeper into this ore body, you start perhaps even having to go to underground. You then start moving in from this free milling oxide ore into a transition zone where you start to have sulfides present, and that's where you can see a drop in your gold recovery. And then if you keep going deeper and deeper into your ore body, you might even see an even further drop in your recovery through just the standard CIL circuit. So really what today is about is being able to help you when you get to this transition zone and deep sulfides to keep operating in this region. So really what we're talking about is maximizing the recovery through your CIL plant. So let's start back at the beginning. You've got your mine, you've developed it, you're accessing this free milling weathered oxide ore, and you're able to get your high recovery through your standard CIL circuit. So there we have our mine, which goes through typically a primary milling circuit. That then goes to our CIL plant, and then we are able to extract the gold from there, get the revenue that we need, and we'll be able to achieve this with very high recovery. Now, when we move in through a number of years as going through the actual deposit, or it could well be that you look at, okay, let's see what's going to be ahead of me in 5 years' time. You start analyzing the drill cores, you start putting that through your standard CIL testing to be able to see what recovery you're going to be achieving. You'll be able to see, oh, am I hitting a transition zone with sulfides? Is that going to be a point where I have a refractory gold deposit showing itself? And is that going to be a point at which we find that the recovery of the gold is not able to be achieved? So why is this recovery not able to be achieved? Its most likely cause of it is you're going into this transition zone, you have sulfides, and therefore, what is the easiest way to deal with this? The easiest way is the sulfides. What do we do in sulfides in the minerals industry? We look at floating them and therefore making a sulfide con. But before we go into the details there, I just want to cover how would you do that flotation. Now here at Glencore Technology, we've had a really good new initiative that we're very excited to talk to people about, which is the full plant Jameson Cell. So the Jameson Cell that itself has been installed in 40 installations of the gold and PGMs, although we have over 300 of the flotation cells within the industry as a whole. So what's different now? If you go to our YouTube channel, you'll be able to have a look at the webinars that we've been doing on the full plant Jameson cells. This is looking at replacing what would be a standard concentrator that you see here with a full plant Jameson cell concentrator that you see here. Now you can see the reduction in cells, you can see the reduction in footprint, but I really recommend you go to our YouTube channel, subscribe to it, watch these videos, and then really be able to understand how you can have an ideal flotation solution to your gold recovery problem. So when we consider that we're going to do our bulk flotation here with the Jameson cell, we'll make our sulfide con. How do we recover that gold? We're not actually recovering the gold in our plant. What we will be doing is then looking at selling this concentrate. Now, as we're selling it, that's going to mean that we have to sell it with terms, and someone else will be able to will be taking the value of the gold because we're not extracting it. But we will still get paid for a portion of that recovery. Now, the question is this actually suitable for everyone? Can you sell that con? Is it actually economic to transport that con? Are you in a location that can actually even do that, considering the geopolitical environment? So these are questions that need to be asked. And then we have to answer, well, what happens if selling the concentrate isn't an option for your site? We then have to look at what do we do next. And so here at Glencore Technology, what we then look at is a staged approach. We then consider, well, what is the next way to understand, can we maximize the recovery through our CIL circuit? And that's where we look at implementing our ultrafine grinding IsaMill technology. So why would we be implementing this? This is because the IsaMill technology is able to have a very tight size distribution, fine grinding with very high efficiency, and you're able to then liberate that gold, which is located within the ore. So really, when you think about what the IsaMill is able to achieve, it's just doing what we achieve with flotation cells. It's liberating, accessing that gold, and being able to put it into operation. Now, you might ask, is this something that we've done before? And actually, we have quite a number of IsaMills installed in this capacity of the pre-CIL grind. And it's the first step that you take when it comes to looking at improving your gold recovery. So it's ideally suited to pirate host the gold, and if you have a more simplified mineralogy of your ore. So then when we look at we're able to implement an IsaMill, that can actually allow us to be able to maintain the recovery. We're putting that through our CIL plant. That means we're recovering that gold. We get 100% of the value of the gold that we recover back into our plant. So we consider, is this something that can happen even when we go into deep sulfides? Now, in some cases, the answer is yes. You are still able to achieve that high recovery. But in other circumstances, even in the transition zone, you may not be able to achieve this high recovery through just iron grinding alone. It might be a complex ore body, or it could be one that is high in other minerals, such as arsenic and the like. So what is it that we do to be able to maximize our gold recovery if just an IsaMill is not enough? This is where we look at implementing the full implementation of the Albion process technology. So the Albion process is combining our IsaMill together with our oxidative leach reactors, and that then forms the basis of our Albion process technology. So therefore, that allows us to be able to achieve this very high gold recovery in all cases of this area. So if we then think about how this would actually be done, what your first question will be, well, what do the results show? Is this real? Is this something that's proven? And of course, what I've shown up here is some a slide from the operation of one of our gold plants. You can see here the sulfur grade. So this is what we see here as input to the plant. We can see the variability that we see in this. This is sulfide grade here. So we're jumping between about 10 to 35% sulfur within the material coming into the Albion plant. You can see here in terms of the gold recovery that passes through the Albion that we're then able to access in the CIL plant, we are maintaining and exceeding our design rate and this being able to hit these high 90s recoveries. So this is something that is possible with the Albion technology, but your next question is going to be, well, if it's possible, where are we doing this? And so really what I want to touch on is this whole process that we've discussed. So when we look at the first implementation, you're going to put in Jameson cells. That's where we're going to have the most of our technologies in this duty. We have over 40 of them in this gold PGM case. And then we look at what is the next step to improving our recovery. Then it is looking at implementing fine grinding, which is the IsaMill of 15 of them within this pre-CIL duty. And then when we look at the full plant implementation, so that is the IsaMill combined with Oxidative Leach Reactor and combined with our oxygen sparging system, the HyperSparge, all those combined together, we have 2 of those installations that have been put into the world. So you can see through this, you work through the economics of being able to implement this, and you look at being able to maximize your gold recovery for your operation. So at this point, what I wanted to do is just not look at what it is that we can achieve, but also then look at taking you through a case study for how we apply this to existing clients. So for this, I'm going to invite my colleague Paul Bullock to take you through this section of the talk. Welcome, Paul.
Thank you very much, Stanko. Yeah, good morning. So I'm Paul Bullock. I'm part of the Hydromet team here at Glencore Technology, looking after the Albion process. So I guess so what we're going to look at today is really what we do is you think you've got a project that Albion's suitable for. How do we take that through to actually fundamentally understand if it is something that the technology is going to work for you? So I guess really the first step is we just to evaluate the option. We look at a few of the key requirements for Albion. So really the Albion process being a sulfide oxidation, obviously, so we need a certain amount of sulfide. I guess so for us to run the Albion so that it's autothermal, we need a minimum of about 10% sulfide in the feed to the Albion. So then looking at that sulfide that we have there, then understanding how much gold is in your feed can then give you, I guess, a really quick indication looking at the gold to sulfide ratio of whether you have an economic project. If we have low sulfide, then obviously, as Stanko's been discussing, we'd be looking to upgrade the sulfide using something like flotation with the Jameson cell. So to do that, you can do standard flotation cell testing, and I guess at this stage we can use that to understand what the requirements of the Jameson cell are, and then moving forward, talking to our flotation team, we would do a dilution cleaning test to actually properly size that equipment later. So I guess if you have something like that, then we would ask you to basically get in contact with us, and we could fill out our process data sheet, and then from that we could use our database materials to have a look at that project and give you an indication of whether we think it would be suitable, and even go through to getting a very high level capital and operating costs. So I guess, so I've done that. We think we've got a project. So how can I prove that it is really a project? So I guess the next step is actually doing a meetability test. So that is actually doing a lab scale bench test that says yes or no, the Albion process is going to work for us. So to do that, basically we're looking at sort of a minimum about a kilo of sample. And we would take that and do a sample characterization, looking, I guess, obviously at the key minerals so that we can understand how it's going to leach and ensure that we do the amenability test in the right conditions to ensure that we get the best result. I guess, and so the amenability test being, I guess, a yes or no test means that we always look for the most optimum conditions to ensure that we give it every chance of working. Once we've done an amenability test, we can then look at doing a class 5 engineering study, which is a sort of plus or minus 40 to 50% capex. So we would take that using our database of mechanical equipment costs. We then do a factored estimate to work that out for you. So I guess then moving forward, so we realised that the Albion test has worked for us, so you want to take it further. I guess there's two key things really to Albion. One is obviously we need to understand the energy requirements so that we can size the IsaMill. So we would do the specific energy curve. And the other key thing for the oxidative leach reactors then is to do a kinetic test to understand the reaction kinetics so that we can then size the leach train. To do that next level of test work, we're looking at quite a much larger sample size of about 25 kilos. And so I guess it's a much bigger commitment, hence why really we do that amenability test up front to really understand that there's a project there to move into. So if we're then going forward, obviously, we have the basic size of the Albion plant. Moving into a class 3 basic, we're looking at the variability testing, and the other key area is probably just in the vendor testing, looking at the solid liquid separation as far as the thickening and those sort of things to ensure that that everything's going to be ready to go. I guess the key part for our design is we can do all of our design from bench scale test work, including offering our performance guarantees. We don't need to take it through to a pilot plant. We do have pilot plant options that are available if it's required as part of your project stage gate process, but it's not an absolute necessity for us. I guess then, so going forward into execution, I guess we like to be fairly flexible in what we can do to work with you to develop the plan and the best options. So really looking at the process design support and doing packages for our key technology equipment, which is the IsaMill and the Oxidative Leach Reactor. We'll then obviously offer construction and commissioning support with us coming to site to help you optimise the plan and bring it up to speed. We also have an agreement with our operating mine at GPM that we can send operators over there to be trained and so that they can get a good knowledge of the Albion process so that we have a really good outcome for your team. So I guess in that, so we have a number of laboratory partners here in Australia. We have Core and we have SGS Lakefield, and then the Tom's Institute, which is over in Russia, and obviously the GPM mine itself. So if you're looking at test work, you can either come and approach us, or you can talk to the labs, and they will also talk to us about any Albion process work that comes through. So I guess at this stage, I know we're going to open up the poll, so be really happy if you could just take the time to answer the poll questions and give us some feedback on our seminar. And now I'm going to pass you over to our Hydromet team, and they're going to have a look at the Q&A questions and answer some of these questions for you. Thank you very much.
Hi guys, my name's Kelvin. I'm here with Dan and Sarah. We're the other members of the Hydromet team. So we've got a few questions that have come through from you guys, and prior to the webinar, we've had a few come through, which is fantastic. So the first one, I'm not going to name names, embarrass people, But the first question that came through was, what is the typical capital and production cost of the combined process? And obviously we get a lot of questions about the dollars, and it's obviously the most important factor for developing a new project, both in terms of capital and operating. So for Albion, it's extremely dependent on the concentrate analysis and the test work results of that concentrate and the amenability test work. So the biggest one we go for is the sulfide concentration in the concentrate, which determines the lime and limestone reagent requirement and the oxygen requirement. So the limestone mill and your oxygen plant are your two big CapEx items apart from the IsaMill. So the IsaMill is determined by your plant throughput and the grind size required, and to the degree by the work index of that concentrate to get it to that target point. So that all comes out in the test work, but the overall operating costs are definitely lower than bacterial and pressure leaching, and the capital costs are approximately about half of the bacterial or pressure leach on a similar concentrate. And we have literature to prove that. So please give us a call if you want to have a chat about that. We can offer a high level operating cost and capital cost estimate based just on your mineralogical analysis. If you want to talk to us about that as well, we don't actually have to do test work to give you that sort of high level estimate. Hopefully that answers your question. So I'll pass it over to Dan now.
Thanks, Kelvin. Hello, everybody. Another question that we got live was which installations are the two full Albion technology sites. I'm assuming this pertains to gold. For gold, we have the Las Lagunas operation in the Dominican Republic, which depleted its resource in 2019. It was in operation from 2012 to 2019. And they've wrapped up. The other operation, which is the full Glencore Technology design, is over in Armenia at GeoPro Mining, or GPM as we affectionately call it. GPM are currently treating a bit of gabbro due to a difficult political situation with their ore supply, but they're still operating their operation. I hope that answers your question.
So I'll jump in on a question that came in around heating and do we need an external heating source for the Albion, and how is cooling achieved? So the Albion process doesn't actually need an external heating source like steam. The heat for the process is provided by the exothermic sulfide oxidation reactions, and these heat the slurry up to about near boiling point, and cooling is achieved by the humidification of the gas stream and by evaporation. So the system comes to a thermal equilibrium, and to cool the slurry before it enters the CIL, you can dilute it with another process stream, or you could run the slurry through an open void cooling tower. So I hope that answers your question. I'll pass over to Kelvin again for another Q&A.
So we had a question come through about the ultrafine grinding with regards to if we grind ultrafine feed, we'll end up with ultrafine tailings, and is that an issue, and how do we deal with that? Which is a fantastic question. It's not one that many people consider. So for a neutral acid leach or a neutral leach for precious metals, we do run it at a neutral pH, and in order to do that, we add lime and limestone as usually limestone is cheaper, we use that to maintain that pH. That reaction with the free acid will produce a goethite and gypsum particles, I guess you call it. There's goethite and gypsum within that slurry. those particles are much coarser. They have a P80 or 80% passing size of about 50 to 60 micron. So that they make it far easier to filter. So you can use a plate and frame, a horizontal vacuum belt filter, or anything you desire. But you don't have that issue of the ultrafines once you've got that larger component. So hopefully that answers that. Back to Dan.
Thanks, Kevin. Other questions that have come through pertaining to fine grinding. We've got a question here about the reduction ratio feeding the IsaMill, and I suppose then the product that is transferred to the leach train proper. Typically, what we've come to deal with often is a concentrate the concentrate particle size distribution will be somewhere between 80 and 60 microns P80, and typically depending on what the application is, in this case let's assume gold, probably be looking at a product specification around 11 or 10 microns P80. That's about a reduction ratio of 6 or 5 depending on the application. So that's roughly about right. There's another question here about the operating temperature and can we get the level of temperature required. The temperature will typically hit very close to the boiling point of whichever altitude you happen to be at. That'll be around the 90-degree mark for a lot of sites, except for our colleagues in the Andes. And so the oxygen requirements for power are a little bit lower, and of course at higher altitude, trying to you will get lesser, like lower power efficiencies from your oxygen plant at high altitude, of course. So higher power though.
And I think we've got time for one last question. So I see one coming in about the types of ores that you can treat. So if you think your gold is hosted in a solid solution in, for example, arsenopyrite, then the Albion process is really for you. And the reason for this is the sulfide oxidation opens up that sulfide matrix. It makes the gold accessible to the cyanide leach after the Albion process. If, however, you think that your gold is hosted at the grain boundaries on pyrite or peritite, then it's possible that you just need the IsaMill component. So this can be determined in the test work, in the Albion amenability test work. And I'll hand over to, or is that?
I think we're out of time, unfortunately.
We will get to all of your questions in any case.
I'm trying to answer as many of them as I can, guys. Just bear with us. I think I'm getting the nod that we're out of time. So I'll have to pass back to Stanko at this point. Thanks for all your questions. That was absolutely fantastic. We will get to you as we can.
Good enthusiasm.
But yeah, thanks guys. Talk to you soon, hopefully.
Excellent. Thanks very much, team. So thank you to Sarah, Dan, and Kel for taking you through all of the questions that have come in. And as they mentioned, we'll get back to you. We'll go through them all and look at answering them over the next couple of weeks so we can send out the information pack as a part of the distribution of this webinar. So just to sum up everything that we've been discussing today, really what we've been talking about is how do we maximize your gold recovery, but then that really is about maximizing your gold revenue through your plant. So if we think about your position, your ore, your mine that you're looking at treating this material through, right at the start, where you've got only a CIL plant, that's when you're getting your high recoveries. But if you then, oh, there we go, we're back, people. Lovely. So as you pass down through the transition zone or go into your deeper sulfides, that's when we're going to start seeing an issue with being able to recover this gold. How can we maximize this recovery to revenue? Because we're looking at this being a transition to sulfides, really the first step is looking at flotation, implementing our Jameson Cell. Now we will get high gold recovery, but we may not get high gold revenue because of the fact that we have to sell this concentrate to someone else to treat it. And therefore we will still increase our gold recovery to revenue, but we are passing on that profit to another company that is buying that concentrate that we've made from us. So this can be an option for many sites and actually, lowest capital, put in that full plant Jameson Cell with a reduced footprint, and you're then able to sell this concentrate and start increasing your revenue to be able to look at recovering those costs. But it may not be applicable to everyone, or you may want to recover that gold within your own plant. And so that's where first we look at implementing the IsaMill. We want to look at fine grinding and being able to access the gold, liberate it, to be able to access it through the CIL. So if we consider that could actually be, as Sarah highlighted, it all depends on how the gold is hosted. The IsaMill may be enough to access it before it goes into the CIL. But if we have more complex mineralogy or how the gold is hosted, the IsaMill may not be enough. We may not be able to get that high recovery with just fine grinding alone. So that's where we have to look at implementing our full Albion process plant. So we need to do the flotation, separate out that concentrate, look at fine grinding and oxidizing it through our Albion process, allowing it to be accessed through the CIL and being able to maximize our recovery throughout the whole development profile of our ore. And because we're treating within the Albion process, that gold is ours, that revenue is ours, and therefore we're able to pass that on to our stakeholders within our company. So in conclusion, I just wanted to thank everyone for attending today. Again, as I mentioned earlier in the talk, if you want to look at any of the webinars, which we've been doing lately, we have them up on our YouTube channel, so please subscribe to it and watch these videos. You also, if you go to our website, you'll be able to access some of our webinars, and even this one. Over time, we're going to be populating our YouTube channel. So please hit the notification button so you can actually find out when our videos are being uploaded. So just to sum up, I wanted to thank everyone again from behalf of everyone here from the hydrometallurgy team at Glencore Technology. And I hope that we've opened up your eyes to the many ways that you can look at implementing our technologies to maximize your gold recovery. Thank you very much.